Just a little bit on me. I am a licensed well driller in the state of Texas. We've drilled somewhere between 750 and 800 water wells, mostly in North Texas. That got us an invite to be a subject matter expert for the Texas Department of Licensing and Regulation. So we are involved with them on a couple of levels. We help with the all of the drillers' exams. We also sit on their General Advisory Council, and we own and operate Barco Well Service in Fort Worth. Been in business about 14 years. We have 27 employees. We are the largest well contractor in the Dallas-Fort Worth area. We also founded Resource Monitor back in 2021 when we needed the ability to connect to some of our customers' source for water. So we'll circle back to that shortly. Since founding RM, it's monitored almost 2 billion gallons of water in 6 states, and that has pushed us to the forefront of talking about conservation and water management, which got us the invite to be on the Upper Trinity Groundwater Conservation District Board. That board manages the busiest groundwater district in Texas. So for the last 3 years in a row, they've had the most new well permits and issued in those 4 counties of any districts. There's 174 districts in Texas. And so we are certainly involved with what's going on in North Texas and around the state. We also have been invited to instruct seminars and talk about conservation and management at the National Groundwater Association. So the point of today's webinar is how to avoid $50,000 water disasters. What could possibly go wrong? It's only water, right? Well, if you are a community manager, that would put you somewhere in this area right in the middle. I can manage it myself. You have to worry about your budget if you're on city water or on groundwater, where you may have to pay for the city water or pay the use fees for groundwater, which then in turn means you're trying to manage the well equipment. And that probably goes into a pond or some sort of irrigation system. And you also have to maintain compliance, whether it's with water restrictions, whether it's with reporting. The different kinds of districts we have around Texas have different requirements. But then you have this next layer of all the things that you deal with outside of just those 4 disciplines. We can help. Resource Monitor can help you operate and manage your water systems in the mix of all of this chaos and busyness. How can we do it? Well, essentially, we remotely monitor your water and help you manage your use. That picture on the right is a flow meter. We have 2 different types. We have magnetics and we have ultrasonics. They are battery powered, so they are very easy to install. They don't require onshore power. They don't require an electrician, no solar panels. The batteries in the meters are rated for 10 years. They communicate with our app using a cell device that also has a 10-year battery life in it. And that water meter and the ultrasonics that are rated to be put in underground boxes. Don't have a picture of that one up right now, but those report to our app every 6 hours through the SMS network via that cell device. That data then is populated on an app where you are capable of monitoring your water usage and your water assets from your phone or computer. We did this several years back because we didn't find anything that we wanted to use on our customers' water assets, and so we created it. So the app that we're going to roll through here pretty quick is designed by guys that are in the water business, and it was refined by a lot of customers that are actual producers and water users in our industry. And so this is our version of how the best way to monitor remotely you can have access to your water assets. So let's look at what our app can do for you. It'll eliminate in-person monitoring. Prior to us being able to connect to water sources, we had to send a tech out to read meters for some HOAs. We had HOA managers that would call us with various different kinds of wildlife in their meter boxes, not the least of which have been snakes and fire ants and scorpions. So our app alleviates the need to go out to a water asset in person. The app is simple to use. It also stores the data that the meters send to the app. And you can monitor multiple water sources all from the same app. We have multiple HOAs that have multiple assets within those HOAs, and all of it can be done from the same application. We also incorporated alerts and alarms into the app when we designed it. Those alerts and alarms are probably the single most useful tool in the app to most of our HOA and community managers. Also, we incorporated a budget and allocation monitoring into the app. We have a lot of our clients in the well company that are set on an annual allocation. If they go over, they pay big penalties and fines, and they also stand to lose part of their allocation from next year. They also have penalties that are cumulative, and so um, if you have a violation in any 2 out of 3 years, those penalties get stiffer and the fines get bigger every time that you have violations. So the budget and allocation portion of the app is big. It keeps our clients from going over their allocation, and it doesn't wait till the end of a reporting period to alert you that you're over your budget. If you have, a well that can produce enough water to go over your allocation in 45 days, it's very important that you know the day that it goes over instead of waiting till the end of a reporting period where you may have used 2/3 of your annual allocation because of an override on some controls. We took that budget and allocation tool, and now we've turned it towards HOA and community managers that may have a line item on their budget where they can give us a dollar figure on their city water, and we can then turn around and translate that dollar figure onto our budget line, same as the annual allocation for our well users. So as we're talking about this, even though we were founded around well water, we have now expanded into now measuring water through pump stations, pulling water out of lakes and ponds, things like that, and now also city water. So don't just turn a deaf ear if you don't have a well in your neighborhood. We are able to turn a dollar figure into an annual volume and keep you on track for that dollar figure as well. So if we're doubling back to the original reason why you joined, how do we avoid $50,000 water disasters? Let's look specifically at some of these water disasters that would be incredibly expensive and talk through how the app helps with some of these and also how we can help avoid waste and avoid fines and penalties and also assist with documentation and reporting. First thing let's look at, these are real world clients that we have on the system currently. This is an example of something we call mineralization, and this is a groundwater asset. And if you look at the picture all the way over on the right, you can see that there is a brand new shiny well pump on the right, and then there's a nasty iron covered pump that has failed there on the left. All groundwater in Texas has got some minerals in it. It doesn't matter if it's here in DFW or if it's in Houston, down in South Texas, the Panhandle. All well water or groundwater has got some mineral in it. In this case, the iron is in the shallowest aquifer. And if we look at our two screenshots here from our app, you can see that there's a certain production level that kind of holds for about 4 or 5 days on this well through the month of August. And then we see the production decline slightly, and then kind of 15 or 20 days in, it starts down a pretty steep slope. We all know what happens to iron when it's exposed to water and air, it rusts. And that's the same thing that this iron scale does down in a well. The more you expose that well bore to air, the faster the rust grows, which then compounds the problem, plugs up the holes in the pump, and this pump just continues to decline in production until it hits a low flow alert. We have a low flow alert set for this well. And when it hits a certain threshold, it notifies us to go out and do a chemical rehab on the well. And you can see there's a partial day here, just to the right of that red arrow, where it's not quite a full block. And that was the day that we did the chemical rehab, and then we returned the well to service. But you can see the next full day that it's measuring, the iron scale bacteria has been removed, and this pump actually takes off, and it is back to the highest production level that it was prior to the mineral incrustation. This is similar to a shower head. We've all seen a shower head that had the little white stuff in the nozzles, and it grows over time, and eventually it finally plugs up that little hole in the shower head. Same thing happens on this pump. But once that happens to a pump, you can see over here, there's an intake right there on that pump that is so plugged up that no water is going in. This will eventually burn a pump up because it takes water flow to cool those pieces of equipment. When you plug the hole and it doesn't get water flowing through it, then you essentially burn this equipment up. It also insulates the equipment so that there's no water moving across the motor that turns that well pump. And so we went with this client from replacing their well pumps every 3 to 4 months when they were using the water to now being on the third year of using the same pump because we're using this feature, this low flow alert, to tell us it's time to go out and deal with mineral incrustation that they have on the well. Another issue that we deal with well water, actually with surface water too, is drawdown. And drawdown is where the pumping level in a well or the level of a surface body of water draws down to the point that one of two things happens. Either the equipment can no longer lift the water, or it starts to draw in air, which is called cavitation. Cavitation will destroy pumping equipment. I know it doesn't make a whole lot of sense to think that if a pump can pump water, it should be able to move air through it, but in fact, that will burn a pump up. It will actually um, cause several different situations, and they're all bad. One is where the air can actually damage the internal parts of the pump by cutting the impellers inside the pump. And it also is kind of a shock load on and off with moving water through this system. Think if you got in a car and were running down the freeway and you just turn the key on and off, on and off, on and off with your foot all the way down on the accelerator. That piece of equipment's not going to last very long. And it's the same with a pump that's moving water. If we look at this graph, the screenshot from this particular asset, you can see that on the far left-hand side, we're maintaining about probably 160,000 gallons a day, roughly. Little bobble here, this was probably a shutdown for some maintenance. And then we noticed that the level in the well draws down to the point that production's dropping off. Again, this low flow alert saved this client a lot of money by notifying them that they need to go out and shut the well down for a few minutes or for a period of time and let the well recapture. They did that. You see the bar here where it was a partial day. The next day, they called us and said, "Hey, come out. We need you to test the equipment." We did some testing. They did some testing the following day and realized that it was drawdown, in fact, but they didn't burn a 75 horsepower pump and motor up. That 75 horsepower pump and motor, if they had burned it up, would probably have been somewhere on the order of $75,000 based on the depth. That's an incredibly deep well. But instead, the low flow alert saved them from having to spend 75,000 for new equipment and having to lower the pump at that point. We were able to come in and add a couple more joints of pipe to the column and set the pump back down where it could, in fact, not see drawdown enough for cavitation. So again, very expensive repair that was averted by the use of our app and some pretty intelligent programming on where they know to set the low flow alerts, and then actually use the app for monitoring their asset. This is another client that we have that avoided a very expensive repair, but this doesn't have anything to do with the groundwater, and it doesn't have anything to do with the equipment. This is actually a situation that was caused by a power failure. And this is something that most people don't know about, especially community managers. But most of our bigger equipment and a lot of the pump stations that pull water out of lakes are all three-phase electricity. That means there's three legs of electricity going into that piece of equipment. Most people's homes only need two of those legs of electricity, and so they have what's called single phase, or only two legs. During the hot part of the year, especially in residential areas where there's not a lot of three-phase equipment, the HVAC load, the air conditioning load, that's generated by a lot of the homes can cause the three legs to get out of balance for a three-phase piece of equipment. And we saw that happen in this location. You can see those bars. It's trying to start and flow water every few minutes here. This is caused by a controller kicking the pump and motor back off, or kicking the controller off so that it's not trying to run on power that's imbalanced. Power imbalance is a very, very bad thing for any sort of electrical equipment. Think washing machine on spin cycle with a load of towels. It will cause an incredible imbalance in the way the motor rotates, which damages pump equipment, damages motors. And so this controller was doing its job, but it's only kicking out about 8.5 gallons before it realizes that the power's out of balance. And so every few minutes you see it kick on, try to pump a little water, and then it kicks back out. This was a 150 gallon a minute pump. So quickly, these folks were losing ground in their pond. They were pulling water out, going to the irrigation system. But if they had not had a low flow alert set, we would not have known this until the surface water, their pond, had been drawn down, and then we're behind the curve and trying to catch back up. On days like today, when it's almost 100 degrees, it's a lot harder to catch back up than it is to maintain. So again, rapid cycling on this pump caused by an imbalance in power, which was the result of extremely hot weather, was caught by our alerts and alarms here, and again prevented the pump and motor from being damaged. We called the power company, told them their three-phase was out of balance. They came out, tested it, and rectified the situation with a voltage regulator down the line, and then we were back up and running. But they wouldn't have known, we wouldn't have known, the HOA wouldn't have known until they saw their lake going down. Then they would have called us, which would have been a slight delay for the service company to get there. Then we would do our testing and then relay to the power company, and so on and so forth. 4 days in this kind of heat or during the summertime is a very long period of time for things to go without water. Another way that we can help is with waste and overproduction and loss. Uh, Most of us have seen in a neighborhood or in someone's yard that picture on the left where a broken sprinkler head is sending water more than likely down the sidewalk into the street and into a storm drain, and it's going somewhere that it's not being used on the property. The picture on the right is a broken pipe, and you can see the pond in the background. That water is just running down the hill back into the pond instead of going to the irrigation system. That's around an amenity center in an HOA. So loss and waste is nothing foreign to us, but let's look at a way that we can help with that with our app and our equipment. This is an HOA irrigation system that you can see at 100 hours in the morning. You can see these various bars. This is just different zones and different run times as it's going through its cycle. Had a big zone right here before it stops at about 3 o'clock and 2 or 3 o'clock in the afternoon. This was probably in the wintertime, by the way. And then we see that the system doesn't ever shut down. These short bars mean that there's a production value for that 15-minute block, 1.5 gallons a minute. This is a sprinkler zone that didn't fully close, or they have a leak in that particular zone. If we look at that mathematic equation, a gallon and a half a minute over 1,440 minutes in a day is about 65,000 gallons of water per month. Depending on where you are, that 65,000 gallons could cost you somewhere north of $500 or $1,000 based on what your city water rate is. So we were able to see leaks as they're happening and make adjustments, notify folks that they need to make repairs, and save this client no telling how much water over an irrigation season. Another way that we are helping prevent waste, I think all of us have probably driven through a neighborhood and seen someone's sprinklers running while it's raining. That certainly is the definition of waste, and we can see that here on our app. We actually track the weather at the closest location to a water asset for our clients, and then we put that information on a graph. You can see this thin blue line right here. This is actually a rain event. If we go over to the right-hand side, we can see it was a 2.5-inch rain event, and it was the 4 or 5 days following an event where they had 6 tenths of rain. So in this week right here, they had a little over 3 inches of rain, but yet this production graph shows for the next 7 or 8 days from that rain event, they were producing 142,000 gallons a day. That is 1.136 million gallons of water that they used when, by all accounts, it seems excessive that they needed to water that heavily for the 7 days after a 3-inch rain event. We are able to track that weather data. We're able to notify users of the system that they have had rain in an area by looking at the app and seeing what's going on. We also track high and low temperature you see down here. This is the kind of waste, 1 million gallons in 8 days, the kind of waste that would put this client over budget at the end of the year. For reference, 1 million gallons of water is enough to um, carry a home of 4 people for about 100 months. So somewhere in the neighborhood of 7 years, a home of 4 people could exist on the amount of water that this particular client wasted over that 8 days. Now, come to find out, they had a float switch that had been disconnected from a controller for one reason or another. They saw it, realized what was going on, shut the well down, got the float switch fixed, and then we're back in production more appropriately here, where the level of the lake was actually dictating whether the well needed to be running or not. Leak detection. This is another area of waste that we see frequently. According to the Texas AgriLife Extension folks, there is something like 700 billion gallons of water a year that goes through landscape irrigation sprinkler heads. And for reference, 700 billion gallons of water would create a river from Amarillo to Houston, a little over 380 miles, and it would be 6 foot deep and it would be 9 tenths of a mile wide. That's how much 700 billion gallons is. According to several sources that we have interacted with over the years, as much as 25% of water that goes through irrigation systems is wasted either through leaks or not delivering it where it needs to go. In this case, we see an irrigation system that comes on at 5 in the morning, goes off about 9 or 8:45, runs through a series of zones, but then again, it never stops pushing water. These little 1.2 gallon blurbs are putting a gallon of water out into the ground somewhere where it's not intended to go, either from a valve not closing or a leaky connection on a pipe or a broken check valve. Something is allowing a gallon every 15 minutes to go out on the ground. So just by putting this up graphically, we allow a lot of our users to see where things are going on, where things are going wrong, and where they need to focus some attention to be more efficient. Another instance, this is a very large pump station that pulls out of a lake. And you can see there's actually a pattern to their zones. You can see these days are kind of similar to these days, and they're kind of similar to these days. And then every 7 days, you have a very tall bar that's kind of in the same neighborhood for these three. But this one right here represents a 40,000 gallon spike. They saw this on their app, noticed it was a significant amount. The difference between these lower bars at 195,000 and this one at 240,000 roughly, that's a pretty sizable spike. 40,000 gallons will fill up most people's medium to large size swimming pool. For visual reference, they were able to see that spike, realize something went wrong, sent their irrigation guys to do a system check on it, and you can see the seventh day after they noticed that, you see the bars going back down to where they need to be for a normal irrigation cycle. Don't know where that water went because I wasn't involved in the repair, but the portion of this bar that is the wasted part was significant enough to draw their attention. So overflow alert kicked on because if this is their normal cycle, they set it at 200,000 gallons. It went over the 200,000 sent an email and a text to the management rep, and then they were able to make the appropriate repairs. This is another way that we help avoid water catastrophes. Again, as I said, the groundwater conservation districts impose a volume allocation on a lot of clients. I know a lot of groundwater districts around the state do that for several different reasons. One can be because of drawdown. Others can be because of subsidence, where the ground actually starts sinking if you pull too much water out of the ground. Others are restricted on some crop production, things like that. But this particular user has a set budget and an allocation for the year. They went over their allocation and it notified them that they were over. And you can see they made appropriate adjustments here. They stopped using the water. They may have let the pond draw down slightly in anticipation of a rain event, or they backed the sprinkler system off a little bit. Then over time, you'll see this line starts to converge back to the budget line. The budget aspect of our program doesn't wait until the end of a reporting period or wait till the end of the year to tell you that you've busted your allocation or your budget. It tells you when you go over so you can make adjustments along the way. As I stated before, this is an allocated well that is on a groundwater conservation district allocation. We can do the same thing for a city water fed irrigation system or project. If you can give us a dollar figure, we can back into this and keep you on budget for the year. The alerts and alarms page is how we do that. Each of these alerts and alarms can send an email and a text. One would be a meter summary. This is how much water went through the system in the previous day. If you need a data export, we can do that for you. We have a communication error that lets you know if the asset went offline. In this case, this is the over budget alert. We have no flow alert, which is self-explanatory. If no water flows, and it should be, it'll send a text and an email. We also have low flow alerts, which are incredibly helpful in notifying us if there is a problem with water delivery, or we have a situation where a leak is going on, and then we have overflow alerts, which we showed you on the previous slide, where the irrigation zones or distribution system had a problem. They spiked and had a 40,000 gallon overuse for that day, and then they made the appropriate repair. So there's a list of our alerts and alarms that we use to help manage a lot of locations for these folks. Here's the low flow alert. Again, this is similar, or it is the same alert that we would get for the power company sending rotten power to that location. It was trying to start, but it wasn't flowing much water. Low flow alert went off. And this slide's pretty interesting. To go from this color green grass in your neighborhood or project to this color, it takes about 4 days now. And so the low flow alert, having the ability to notify us within a day if no water flows, is certainly something we can cover as well. Another way to avoid water catastrophes is to avoid fines and penalties. Made reference to groundwater districts, conservation districts, and subsidence districts a few minutes ago. This is a map of the ones that are in Texas. You can see they're not everywhere. Some of them down around Austin are broken up by aquifer. In North Texas, there are 3 and 4 county districts. There are some single county districts down here along the coast. We see some subsidence districts that are trying to prevent the amount of groundwater being pulled out from actually making the ground sink. What we can do on the app to help avoid fines and penalties, we generate reports electronically with very accurate data, and it's timely. Nearly every one of these districts is going to require some sort of water meter reading off of a well or an asset every month. They may not require you to turn it in every month. Some require reporting every 3 months or 6 months, but they do require it at the end of a month. Our app reports every month, generates a report at the end of the month for every water asset automatically. And so the reporting is taken out of the hands of those that can forget it. I mean, we've had irrigation contractors that forgot to read meters. We've had homeowners in a subdivision or neighborhood that were supposed to be reading the meter and they got behind and had no readings for an entire year. And then certainly that generated fines and penalties. So having accurate data and having it on time is a very important part of what we do to maintain compliance and avoid penalties and fines. For community managers, um, just kind of in summary, the benefits of us coming on board alongside you to help with managing your water assets. We can alleviate trips to projects or neighborhoods for inspections or to read meters. Fewer trips allows you to go do more proactive things, certainly. Cost savings to your clients by helping avoid costly repairs and penalties and fines associated with non-compliance. We can reduce equipment downtime. Going back to looking at those wells that we have avoided serious failures on, it's one thing to save money and not have those repairs. It's another thing that compounds those kind of costly repairs when we get into summertime and maybe we're 3 or 4 days out from being able to get to a major repair. That situation is very hard to deal with when you're trying to keep landscape alive during the hottest part of the year. So downtime is a huge part of proactive management and maintenance. Accurate data and reports for compliance, we talked about that. The alerts for waste and for managing what water you do have and where it goes. Then the budget alerts for allocation and also for the city water part of an irrigation system, which, by the way, a lot of HOA reps that are on city water that we've talked to have said that that is their single largest budget item in their annual budget is water. So having those budget alerts to keep you on track by the day, certainly something we can help with. And then weather tracking in the app to know what's going on in your neighborhoods or the closest weather observation site in the neighborhoods. That's what we do. I am available. There's my contact information. If you're watching this, you more than likely are interested in some sort of assistance with managing water or avoiding water catastrophes in your neighborhood. We would certainly like to show you what we've done in the past and what we're able to do with our equipment. And we are here to help connect you to your source. Appreciate you guys logging in.